Assalamu alaikum. Today we're going to cover the outlines, only the outlines of the physical geology course presented by Khalid Lamrouni, PhD in geology from Texas A&M University. And Khalid Lamrouni now is a staff member at the Earth Science Department, Garyunis University, Benghazi, Barga State, or Serenaka State. This is the Geology Department or Earth Science Department at Garyunis University, and this is the main office of Garyunis University or the main entrance. Introduction to physical geology. At this introduction, we're going to cover two broad areas of geology, physical and historical, and we're going to cover two important theories in geology, catastrophism theory and uniformitarianism theory. And then we're going to cover the solid earth, which is basically the inner core, outer core, and mantle and crust, and two important zones, asthenosphere and lithosphere, and the processes that alter the Earth's surface, destructive and constructive forces, the Earth's physical environments, the three physical environments, the atmosphere, hydrosphere, and solid Earth. And then we're going to study plate tectonics that has three distinctive types of plate boundaries: divergent, convergent, transform, or fault. And the divergent boundaries, mainly seafloor spreading and oceanic ridges. And convergent boundaries, subduction zone, three types of convergent boundaries we have here. Then we'll go to Wilson cycle or tectonic cycle. That's basically talking about opening, closing of oceanic basins. The rock cycle and geological process. The rock cycle is very important in geology and shows like the process of the magma, how it transformed to igneous rocks, and then sedimentary rocks, metamorphic rocks, and then we'll study the geological processes that worked on these transformation, which are crystallization, weathering, erosion, cementation, compaction, lithification, pressure, and temperature. And then we'll study the hydrological cycle that consists of rainfall, infiltration, runoff, evaporation, transpiration, and rainfall again. And then the interaction between the rock cycle and the hydrological cycle. That was the introduction. And now we'll go to the next chapter, plate tectonics, continental drift, chapter 2. And we'll study the continental drift and the Pangea or Pangea that formed 200 million years ago and then broke up. And we'll see the fitness of the continents, how we could fit them, the sites of the continents, and fossil evidence. And then we'll look at the Wagner's proposed two possible energy sources for the drifting. He proposed the tidal influence of the moon and the continents broke through the oceanic crust. And both wrong. Plate tectonics brought the correct answer, and they call it a modern version of an old idea. Through seismology, seismic activity, volcanism, and mountain building that occur along these dynamic margins. The plate boundaries, there are three different types of plate boundaries discovered by the plate tectonics. Divergent boundaries, convergent boundaries, transform, fault boundaries. And then plate tectonics and its relation to paleomagnetism, polar wandering, earthquakes, hotspots, and driving mechanisms of the plate tectonics. We'll be studying that chapter. Now, matters and metals, chapter 3. Here we'll study rocks, minerals, physical properties of minerals, crystal form, luster, hardness, Mohs scale, cleavage, fracture, specific gravity, color, and streaks. Rock-forming minerals are both silicate and non-silicate. Silicates, ferromagnesian silicate, and non-ferromagnesian silicate. And then we'll study Bowen's reaction series, which is mainly the sequence of minerals crystallization from a magma. B, non-silicate minerals, carbonate minerals, calcite and dolomite. And other non-silicate minerals, halite and gypsum. And then we'll look at common non-silicate mineral groups. Chapter 4, igneous rocks. On igneous activity, igneous rocks, intrusive plutonic, extrusive volcanic, crystallization of magma, and we'll look at the crystallization process, and then igneous rocks classification, texture and mineralogy, Bones reaction series, fractional crystallization, evolution of magma, magmatic differentiation, assimilation, and magma mixing, and then partial melting, and then naming igneous rocks, felsic, intermediate, and mafic. Felsic usually call them light, mafic we call them dark. Pyroclastic rocks, tufa rock, wooded tuff, volcanic breccia, lava versus magma, differences between them. And then igneous activity, chapter 5, that will be the nature of volcanic activity, materials extruded during an eruption, lava, gases, pyroclastic materials. And then volcanoes and volcanic eruption, the parts of the volcano. Parts of the volcano are chamber, vent, calderas, fissures, flanks, parasitic cones. And then 3 groups of volcanoes, 3 main groups: shield volcanoes, cinder cones, composite cones, or they call them stratovolcanoes. Formation of calderas, fissure eruptions, pyroclastic flows, variations in properties among magmas and of different compositions, intrusive igneous activity and their classification based on shape and orientation. For example, dikes, cells, localiths, and batholiths. Hotspots, igneous activity and plate tectonics, origin of magma, melting point, partial melting. Distribution of igneous activity along oceanic ridges, oceanic trenches, and within the plates themselves. Review of igneous activity, igneous rocks form when magma cools and crystallizes. Intrusive plutonic rocks, extrusive volcanic rocks. The crystallization processes are influenced, or the crystallization process is influenced by the rate of cooling, the metallurgical composition of magma, and the amount of volatiles. Weathering and sedimentary rocks, chapter 6 and 7. Weathering and sedimentary rocks. Weathering are 2 types of weathering. There are 2 types, mechanical and chemical, and we study rate of weathering as well. Erosion, mass wasting, soil, control of soil formation, the soil profile and soil types, sedimentary rocks, types of sedimentary rocks, detrital and chemical. And then we'll study here processes, turning sediments into sedimentary rocks, lithification, compaction, and cementation. Classification of sedimentary rocks will be studied, features of sedimentary rocks, such as stratification, deposition environments and facies, energy resources from sedimentary rocks. And then metamorphic rocks, chapter 8. We'll study metamorphism, 3 settings of metamorphism during mountain building, contact metamorphism along fault zones, agents of metamorphism, heating, pressure, chemical activity, fluids, or chemically active fluids. Textural and metallurgical changes, foliation and foliation, what drives metamorphism, inherent rocks and metamorphic grade, metamorphic texture, occurrence of metamorphic rocks, metamorphic environments, metamorphic zones, and index minerals to know the grade of metamorphism. And here the map of Barga state, Cyrenaica, and here the flag of Cyrenaica behind the Prince Idris Senussi. Here the Prince Idris Senussi, Prince of Cyrenaica 1949. And here Omar al-Mukhtar, the chief commander of the Senussi army, and this is Benghazi, the capital of Cyrenaica, and this is the national anthem of Cyrenaica. We'll get 3 minutes rest, and then we'll continue through the outlines of the physical geology class. Now we're going to chapter 9, earthquakes and earth interiors. Earthquakes and earth interior. What mechanism does produce a destructive earthquake? Crustal uplifting, subsidence, horizontal movement. And then we'll study seismology, seismographs, seismograms, two main groups of seismic waves, surface waves and body waves. Body waves divided into primary or P waves and secondary or S waves. Waves, method of travel or method of propagation. P waves push and pull, compress and dilate. And S waves shake particles. Location of earthquakes, how to find it. Earthquakes, intensity and magnitude. The Earth's interior for major layers, crustal, mantle, outer core, and inner core. And then we'll study Mohs discontinuity, the shadow zone, asthenosphere, lithosphere, composition of the Earth, mainly granitic rocks for continental crust and basaltic composition for oceanic crust. Ocean basin, origin and evolution of the seafloor, chapter 10. The ocean floor, measuring, first thing, how to measure the depth of the ocean. Weighted lines, old method. Echo sounds, and then the latest is satellite radar altimeter. Types of seafloor sediments, lithogenous derived from rocks, biogenous derived from organisms, and hydrogenous derived from water. Seafloor sediments and climate, three major units of the ocean basin: continental margin, the ocean basin floor, mid-oceanic ridges. Continental margin, or any continental margin, includes continental shelf, continental slope, and continental rise. The ocean basin floor includes trench, deep grooves, abyssal plain, flat-sided, volcanic peak, seamount. And we might see there coral reefs and atolls, and then we'll study oceans opening and closing, which is Crustal deformation and mountain building. Chapter 11, deformations that we have faults, and joints. Stress that apply to rocks, compressional, tensional, and shear stress. And the product of the stress is strain, or response of the stress, strain, elastic, brittle, and ductile deformation. Factors that affect rock strength, temperature, confining pressure, rock type, and time. Length of time. Faults, anticline, syncline, monocline, domes, and basins. Faults, dip slip fault, and strike slip fault. Dip slip faults includes normal, reverse, thrust, and horse and gravel. Transform and strike slip faults, they are called transform faults. And then we have joints, we have mountain building, and then the principle of Basins. Mass wasting, chapter 12. The importance of mass wasting. First item. Landslides, a geological hazard. The role of mass wasting in landform development. Slopes change through time. And then controls and triggers of mass wasting. The role of water always there. Oversteeping slopes. Removal of vegetation. Earthquakes as trigger. Landslides without trigger. And then we'll look at the angle of repose. Classification of mass wasting process. There are 3 types. Classification based on type material, type motion, rate of movement. And then running water, chapter 13. We'll study here the hydrological cycle, and of course we'll study stream velocity and controlling factors, which are gradient, shape, size, and roughness of the channel, and then the discharge. Changes downstream, load, and their relation to the load and discharge, base level, ultimate and local, the graded streams, work of streams, erosion, transportation, and deposition. Stream ability, its competence and capacity. Transportation, 3 ways: dissolved load, suspended load, bed load. Transportation of rivers or streams. Stream channels: 1 bedrock channel, 2 alluvial channels that has meandering and braided streams or braid channels. Stream landforms, deltas, the product of the stream landforms, deltas, natural levee, alluvial plains, flood plains. 2 types of stream valleys: narrow V-shaped valleys and wide valleys with a flat force. Drainage systems and patterns, stages of valley development, incised valley and terraces, floods, and flood control. Groundwater, chapter 14. The hydrological cycle, groundwater, distribution of groundwater, zone of saturation, underwater table, we call it phreatic zone, and then water table, and then zone of aeration above water zone, we call it beta zone. That includes air and water. The water table, we studied effluent streams, we call them gaining streams, and influent streams, we call them losing streams. We'll study porosity and permeability, aquicludes versus aquifers, springs, and Persian water tables, and then we'll study wells and their cones of depression. We'll study artesian wells and the 2 conditions that must exist to have an artesian well. Environmental problems, hot springs, geysers, and geothermal energy, and then the geological work of groundwater, mainly erosion, dissolving rocks, especially limestones, creating caves, caverns, dripstone, speleothems, stalactites, soda straws, and stalagmites. Karst topography, sinkholes or sinks, formation of sinks. Chapter 14, glaciers and glaciation. We'll study what's a glacier, snow field, snow line, alpine glaciers versus continental glaciers. Glacier movement, 2 ways: internal and the whole, internal movement and the whole ice mass. Zone of fracture, crevasses, calving, and ablation. Glacier erosion, 2 ways: blocking and abrasion. Rock floor, glacial striation. The ice modifies streams in 3 ways: widening, deepening, and straightening valleys. And we have a glacial trough, hanging valley, cirque, fjord, arêtes, and horns. Arêtes is a French word here. Glacial deposits, 2 types: deposit directly, we call it tellites, very ill sorted, and deposited by glacial melt water or outwash stratified tills. Moraines, outwash plains and kettle holes, drumlins, eskers, and camps. Glaciers in the geological past, Ice Age, Pleistocene epoch, some indirect effect of Ice Age glaciers, causes of glaciation. Deserts and winds, chapter 16, we'll study here deserts, plants of the desert, zoophytes mainly, distribution of dry lands, low latitude, dry climate, geological processing, arid climate, mechanical weathering mainly. Middle latitude desert steppes, transportation of sediment here mainly by wind at the desert. Okay, bid loads and suspended loads, wind transport, bid load, wind erosion, deflation, blowout, desert pavements, and ventivacs, wind deposits and deposit dunes and silt deposits. And types of sand dunes, Barracan dunes, transverse dunes, longitudinal dunes, we'll call them safe dunes, safe coming from the Arabic word sort, and parabolic dunes. The evolution of desert landscapes, alluvial plains, Bajada, Playa Lakes, Piedmont, and Inselbergs. Here, Inselbergs. Yep. And then Shorelines, chapter 17. Shorelines are dynamic interfaces. Basic features of subdivision: foreshore, backshore, nearshore, offshore, and beaches. Waves, wind-generated waves. Wave basics: crest, trough, wavelength, wave height. Waves of oscillation and waves of translation. The work of waves: wave erosion, sand movement, wave refraction, longshore transport, rip currents, shoreline erosional features, wave cut cliffs, the wave cut platforms, sea caves, arcs, sea stacks. Shoreline depositional features: spit, bay mouth bars, tombolo, and barrier islands. Barrier islands have three mechanisms to form. We'll study them. The evolving shoreline is another title. Tides, causes of tides, the gravitational force of the moon and sun, monthly tide cycle, spring tide and neap tides. High tide period, low tide period, tidal currents, tide rises, flood tide versus tide falls, ebb tide, tidal flats, tides, and Earth's rotation. Contrasting Americans' coastal lines, coastal classification, emergent costs versus submergent costs, human interface with shoreline process, stabilizing the shore, hard stabilization, making jetties, groins, and breakwaters, alternative to hard stabilization, which is beach nourishment and relocation. And then we'll study hurricanes, the coastal hazard profile of a hurricane. We'll study it in hurricane destruction. Geological time, chapter 18. Here we'll study numerical absolute age and relative age dating. So, relative age dating, we use principles: principle of superposition, principle of original horizontality, principle of lateral continuity, principle of cross-cutting relationships, principle of inclusion, principle of conformities. In correlation of rock layers, we use fossils for correlation. Principle of fossil succession: one, index fossils; second, a fossil assemblage. And we can use fossils also, besides being age assistant, we use them as environmental indicator. Now, absolute age dating, we use radioactive isotopes and half-life time. We use potassium argon, we use uranium-238, lead-206, and we use carbon-14. And then we'll look at the geological time scale. And by this, we concluded the outlines of this course material. And this is the CV of the presenter, the education of the presenter, and teaching interests of the presenter, and recent publications and presentation of the presenter. And by this, we're done in academic research. Yep.